Work it, make it, do it, make sense.
Good morning, everyone, and welcome to my talk, How to Build a Connected Product. I'm Jeroen Mols, I'm Belgian, and I've worked on various connected products before, most of them Philips products, and currently I'm working on the coolest IoT system in the world, which is Philips Hue. We already have quite some amazing use cases that we support, but we have some even more awesome features in our pipeline. So if you're interested in helping out building those, we're hiring quite significantly, actually. So you can check out our career page there. And if you have any questions about this talk later on, you can always follow me on Twitter. So today we're talking about connected products. And to set the scene right, it's not enough for your code to work. Whenever you're building something that you're going to ship to users, they're going to use it for quite some time, so it doesn't just need to work, it needs to continue to work. You need to be able to handle all of those legacy cases. So it takes quite some good engineering practices to get this right. Now, what is actually the challenge in building a connected product? Well, imagine if you build a simple product like a speaker. Everything nowadays has software into it, so even a simple speaker would have some software. It gets more interesting when you add a smartphone to the mix, because then you're communicating over, for instance, Bluetooth LE, so there's a lot more cases where stuff could go wrong. The downside still is you cannot really control your product via the internet, because the product doesn't have any connection to the internet. So if you want to support that, you need to add Wi-Fi connectivity, and suddenly the Wi-Fi router comes into the mix. And while you might think like, yeah, so what, it's just a Wi-Fi router? Well, that's not really true, because there's a lot of crappy routers out there who really don't handle your connections well, and they also may not support every technology. Like, for instance, UDP, multicast, those could be troublesome in the field. But yeah, only connecting your product when you're at home, that's a bit boring, so you also want to add your own backend so you can allow out-of-home control. And yeah, if you really want to have interesting use cases, you could consider adding a bridge, which is an always-on, always-connected device. For us, for Philips Hue, we actually are bridging technologies. We're bridging from Wi-Fi to Zigbee, so we need to have this actually as a bridge. But it also simplifies our Wi-Fi setup. It adds implicit security. We can run automated routines, so home automation scenarios, and more stuff like that. So adding a bridge over the long run could be an interesting approach. But yeah, you're not aiming just to build one product. You're building a system, right? So after a while, you're going to add similar products or completely different products. Yet still, some way or the other, you need to be able to support all of that via one entry point into your system, for instance, your mobile app. So there's hardware diversity to take into account. But not just over there, also your bridge could have Wi-Fi, could have hardware diversity. We, for instance, have 2 different bridge versions because we needed to support Apple HomeKit. And apparently asking users to solder a new chip into their existing bridge isn't really a good UX, so hence we launched a new bridge. And there could be other cases to control your system, like via a smartwatch or any other integration you can imagine. A cloud-to-cloud integration, another connected product in your home. So this stuff gets really, really complex, really, really fast. And to make matters worse, for Philips Hue, it's even more complex, because every single part in our system is software updatable, so you can have different software versions. Plus, we not just have power devices, we also have battery-powered devices. So yeah, if you add all of those things up, it's challenging to build a connected system. To me, the main challenges are how to make sure that users still understand what you're actually doing. So how to make it understandable for users. And obviously also how to make sure that your system works and works well in the first place. And how can you handle all of that diversity, all of that legacy? How do you handle that? How do you cope with that? So this is basically what we're going to look at in this presentation. Only the last part, the handling diversity and legacy, that's such a complex and broad subject that I won't be able to cover it completely in this talk, so we're just going to touch base there. Okay, so first things first, how to make stuff understandable for users. Now, I guess this is the single most important thing if you're building a connected product, is making sure that users can actually set it up. They go to the store, they buy your shiny new product, for instance, a speaker, but how on earth can you connect the speaker to your Wi-Fi network? It doesn't have a display, so you cannot select which is the SSID of your particular home network, nor does it have a keyboard, so you cannot enter the Wi-Fi password. Yet users need to be able to get it set up, because if this doesn't work, yeah, that's a returned product, because users are completely lost. So this is the crucial aspect of your system. How does that work? Typically, you'll ask the user to do some kind of interaction with the product, so press a button or first time powering it up, and that's going to make sure the product starts its own Wi-Fi network, a setup network, typically an insecure network. The phone can then switch from your home network to the setup network and send over the SSID and password of that home network. Then the product switches back to your home network, the phone does the same thing, and if everything goes well, then you're successfully set up. Sounds easy enough. Now, if you look at a practical scenario, how for instance CHROMECAST does it, the first thing that you should notice is that it's a lot of screens, and that's almost always the case like that. Setting up a product is quite a tedious process, and not every user is technical. Most users actually aren't technical, so you want to really grab their hands and step-by-step guide them through it. So, same for the CHROMECAST. How does it work? First, they ask you for your location permissions. Well, this is odd. I just want to set up a product. But you need to be able to scan for Wi-Fi networks around you and to be able to detect products. And because you could implicitly locate somebody based on the networks that are around them, you need to ask for location permissions. Then you actually scan for devices around you. And once you've found the device, here the CHROMECAST 4244, then you're ready to actually start setting it up. So, the first step is actually to connect to the network of the CHROMECAST. So now the CHROMECAST has opened up its setup network, and the phone is going to connect to that network. By the way, network connections are rather slow. So if you need to configure a new network and swap to it via an app, that could easily take like somewhere between 10 to 30, 50 seconds if you're unlucky. On Android, you can do this in the background automatically. On iOS, you cannot do this. On iOS, you need to ask the user to basically leave the app, go to settings, and then select the Wi-Fi network and get back to the app. So that's, yeah, quite tricky for users, because once they leave your app, they don't have any context of what to do anymore, so you might already lose them there. But imagine if you get connected to the CHROMECAST, then you optionally could confirm that this is actually the CHROMECAST that you want to set up, and not the one of your neighbor. You could give it a name and enable some other options. And then we get into the really interesting part, which is telling the product which network it should connect to. And this is where it goes wrong in 99% of the cases. Because I don't know about you guys, but my Wi-Fi password at home is rather random. And have you ever tried entering like 20 random characters on a very small keyboard? That's not a fun experience, especially if you need to swap from alphabetical keyboard to numeric to symbol keyboard, back and forth, back and forth. It's really a tedious process. And it's even worse because if you enter the Wi-Fi password, we can't simply do a simple REST call to see if that was the right password. We need to actually ask the product to disconnect from its setup network, try and connect your home network, and only when that fails, then you would know if the password was correct or not. And that could easily take around a minute. So it's a complex thing to do, and the feedback loop is really, really long. So this is where most users, simply don't make it through. An additional aspect to this, by the way, is that a lot of people simply don't know that they have a Wi-Fi network, because typically your telecommunications provider just comes to your house, installs some kind of router, sets up all of your products, and then a lot of users don't even know that they have Wi-Fi, let alone that they have a Wi-Fi password. So also that could be problematic here. Now, good news, at least for Google and Apple, they have a solution around that. So Google, they're able to autofill the Wi-Fi password for you. I'm guessing that they are fetching this out of your backup, so your Android backup, that are just fetching the Wi-Fi password from there. Android does it slightly differently, but they also don't need this step. But these solutions aren't open to all of us. So if we want to build something like that, you need to ask the users to enter the password. So once the password is entered, your Chromecast is going to try and connect to your home network. Your phone is going to connect back to your home network. And if both of them succeed, boom, you're ready to go. So it should be clear that this isn't a simple thing to do, because entering the passwords is problematic, like I already discussed, but also switching those networks is very, very fragile. That goes wrong in more cases than you might think. I'm going to show you a diagram of all of the bad weather scenarios later on. That's not a fun thing to build. And then even if the switching goes well, some phones avoid networks if they don't have internet connection, which a setup network by default has. So then they would, every time you try and connect to them, they would just disconnect automatically. Or also your operating system, your Android OS, could simply refuse to direct your traffic over that network. If you would now look at the bad weather scenario, so this is when we, in 2011, originally designed the Wi-Fi setup flow. These are quite a couple of screens to build, and it doesn't even take into account every possible thing that could go wrong. So it's really, really tricky to get this right, but you must get it right, because if you don't, it's a returned product. Now, an example of, for instance, how an operating system change, because also the operating systems on your user's phone is going to change, how that could affect your Wi-Fi setup flow. So Android 5.0 decided to do things differently. Before, if you would be connected to a Wi-Fi network without internet, then Android would just don't care about it and redirect every request over the Wi-Fi network as you would expect. But starting from 5.0 and higher, they decided to be a bit smarter. So if your Wi-Fi network would have poor connectivity, but you would have a working 3G, 4G connection, why wouldn't you route everything over that connection? So they started doing that. And then you may say like, but they're smart enough to see if this is an IP address on your local network, so then not reroute that traffic, right? Well, actually they weren't. So suddenly Wi-Fi setup completely broke. There's luckily a way around that. So in the presentation, there's going to be sometimes a bit of code. I'm an Android developer, so it's typically going to be Android, but it's mostly to give you the gist of things that could go wrong and that you get the general problems. So you need an API check. Then you can ask like, hey, I want to use a Wi-Fi network. So you make a network request and you ask for a Wi-Fi network. You ask the connectivity manager, hey, I need to use this Wi-Fi network. Let me know when I'm ready to use it. And then on available, you could start using it. This is if you want to do it for one request, but you could also do it for all requests, which is exactly the same. The only thing that changed is that in unavailable, you bind process to the network, and then every subsequent call you would do would go over the Wi-Fi network. Okay, so if this Wi-Fi setup is so problematic, aren't there any good alternatives? Yes, there are, and probably the best one is just to have a product which is hardwired with an Ethernet cable to your router. That's what Philips Hue does, but like I said, we need to do it because we need to bridge from Wi-Fi to Zigbee, but also other products like Sonos also used to do that for the longest time. There's also this technology called WPS, Wi-Fi Protected Setup. Does anybody know about that? Yeah, so I see a few nods, but not even the entire audience. Well, this used to be like the silver bullet. You just press a button on your router, you press a button on your product, and if you would do that in a particular time frame, then both of them would do a Wi-Fi password exchange and it would be connected. Well, besides that technology being plagued with many security holes, it actually also, not every router in the field has it, and if a router has it, the button always looks differently, and many people don't know that they have a router, so it's somewhere tucked away in their metering cabinet, so people simply can't figure it out, WPS. So it's basically a broken promise. What you could do, however, is instead of using the Wi-Fi network, which switching Wi-Fi networks is fragile, you could send over the password and the SSID in a different way, like via NFC or high-frequency sound, which is really, really cool. That's also what they use, not for the Wi-Fi setup, but what they use in the CHROMECAST, by the way, because high-frequency sound has like the nice tendency that it doesn't travel through walls. So you have the implicit security that only you're sending it within your own home. They use it for the CHROMECAST guest mode, by the way. And then the last alternative is to use WAC. I think it's wireless accessory configuration, which you can only do for HomeKit devices. And in order for that to work, you need to have an Apple chip in your product. But if you have that, then for all of your users, that will be a non-issue because Apple takes care of that for you. Okay? Should you go with the approach that I first described? A very simple pro tip is make sure that all of the products have a random setup SSID. Because otherwise, if you're debugging your product or you're testing it out on your work floor, multiple people could be doing the setup at the same time, or somebody forgets to put their product out of the Wi-Fi setup, and then you're going through the setup and you have no idea which of the products you're setting up. Extremely annoying, been there, don't do that, and even the CHROMECAST does it, they just append a couple of random characters to their setup name. Okay, now, so user experience, first part, Wi-Fi setup, that's covered. Now, good versus bad weather scenarios. We're going to look at another setup flow. This has nothing to do with Wi-Fi setup, but this is basically we're commissioning a new product into our already connected system. In September, we launched a new motion sensor. And if you want to add a motion sensor to your system, what you basically have to do is users need to pull the battery lid, so the motion sensor gets activated, and then it starts searching for a network to join. Then you need to tell the bridge to look for that motion sensor. Once it's found it, you select what room you want to use the motion sensor in, and then we set up everything for you. So in essence, this is like a super great experience, right? Because users select their room, and depending on that room, we already select the right defaults, the right timeouts, the right settings, the start, end times, and so on. We program the dynamic behavior, so during the night, your lights will only go on dimmed. During the day, they will go on full brightness, only if it's dark enough in the room, stuff like that. We do all of that heavy lifting for you. But that's, of course, in the happy case. In the bad weather scenario, you could be looking for a motion sensor and not find anyone. Or you could find multiple ones. Or what if you find one, and then your phone runs out of battery and it just shuts off. So then you're left in an inconsistent state because you have a product added to your system, but it's not configured. Same for room selection. There could be no room in your system. Or another app could be removing those rooms as you are selecting them. Or the type of the rooms, because we rely on the type of the rooms to give you the right default. You could look at the icons of the room, so the living room and the dining room could have a different icon. But users might have missed that and just only change the names of the rooms, so also the dining room could actually be a living room. So then they would get the wrong settings. And of course, when programming, we already can think of all of the things that can go wrong, network requests that failed, your bridge could be full. We're relying on timing. So what if the bridge reboots somewhere or crashes and it just needs to reboot? It doesn't have an internet connection. Will it then still have the right time internally to trigger those kind of things? So many, many bad weather scenarios. I'm just listing a couple of those here, but the entire gist of it is it's nearly impossible for you to reproduce those manually. And even if you could, it's impractical because it's so many of them, and you always need to make sure that you're able to cover regression. So you need something that scales better. So what I would suggest is that you build a simulator, not like a system simulator, so that you actually have a separate application running on a laptop which you're connecting to be able to simulate all of those things. We actually have that within you that also has its benefits, but just something very, very simple built into your product itself. So in our case, to be built into the app itself. And that could then just provide us with hard-coded responses, simulate dynamic behavior, and also make sure that we can reproduce those bad weather scenarios. A very simple way of doing that, because it sounds hard, but it isn't, because if we're building a product like we described before, you already have two ways of communicating to that product. You can either locally on the Wi-Fi network send direct requests, or do something over the RESTful API of your backend server. So you need to be able to switch between both of them anyways. So you need to have some abstraction, which could very well be a strategy pattern. So why not add a simulator strategy? A very, very simple class, and you just hard code some of those things in there. And then, for instance, the dynamic behavior, I could very simply code in there that if I open up my app and it's a debug build, that it just starts shifting the UI from red to green to blue to red to green to blue, so that you have some dynamics to look at. Very simple and works very, very well. A pro tip to end off this section is don't talk about devices, because what is a device? Any single one of those things could be a device. So it's better to use the term product, so you're explicitly stating like we're talking about the speaker or about the bridge. It sounds simple, but the terminology could get quite confusing. So, next up is making sure that your system actually works and that it's performant. Now, first of all, the discovery. So imagine if your products are actually connected, how can you find those back? Hey, you open your app or a desktop application, you need to look for the products you're actually able to communicate with. Well, basically, if you open up the app or the controller, then you need to do two things. You need to know which are the products I can talk to remotely and which are the products I can talk to locally. So you need to run both a local and a remote discovery. Local discovery works fairly simple. It's typically multicast based, so your phone would send out a message like, hey, I'm looking for products which are able to do this, and those products would either reply directly to the phone like, hey, here I am, or they would also broadcast the same thing. Typical examples are SSDP or MDNS. As fallbacks, what you could do is you can do an IP scan, so you just take your subnet, see all of the IP addresses which are in that range, and then one by one try to connect to them, which is a very brute force mechanism. It does work, but it consumes a lot of resources and it is slow. Or you could ask the user to enter a manual IP address. Or, and this is actually quite an interesting approach, is to have some kind of proprietary IP server. So what you can do with Philips Hue is you can just call this link, so on any device, on your laptop, on your phone, doesn't matter, and it will return you all of the products which are connected behind your external IP address. So this is a very simple way of getting the IP addresses of all of the products on your network. And the real interesting thing about this is that this is, besides the manual IP, the only approach that actually works in a web app. So that's also one of the main reasons why we've built this. Remote discovery is different, but as you would expect, so your phone communicates with your backend server, there's some authentication there, it asks the server which are the products I'm allowed to communicate with, because it cannot, the server knows about all of the products in the entire world, but the user isn't allowed to simply control those, so there's some kind of implicit security there. The server returns, these are the products you're allowed to connect to, and then the phone could just start connecting to them. Now, one important thing here is, before this can work, you need to have set up your product locally, because it needs to be able to contact your backend regularly to tell the backend like, hey, here I am, this is my IP address. So, let's now look at a very simple app, where we actually try to optimize this and make it as fast as we possibly can. The worst case scenario is when you cold start an app. So you completely kill the app and then you start it from scratch. You have no idea where the user may be, so he could be either at home or he could be at work. So you don't know which products are going to appear locally, which remote, and yet you want to make that super, super fast for users. Well, the first approach would be like, if the app starts, let's simply look for all of the products that are local, look for all of the products that are remote, so we start a local and remote discovery. Once we found those, we're going to connect to them, which is nothing else than just fetching their latest state, so we can show something meaningful in the UI, and once we have that, users can start controlling them. That would look something like this. The app starts, we see a spinner, we're searching for devices, we found the local ones, the remote ones likely later, now we're connected to the local ones, and now we're connected to the remote ones. So, works effectively, but it's rather slow, so not a great user experience. Even more, imagine if for some reason you can't find any products at all, your screen would be empty, which really sucks from a user point of view. So, how can we optimize this? Well, the most straightforward thing to do is simply store the products in a database. If you store them in a database, you still need to run your local and remote discovery because you don't know their IP address or their connection state to connect to them, and you also still need to fetch their latest state because, otherwise you can't display something in the UI. So basically, this is as slow as the previous mechanism, only it looks nicer for a user. So we start, we can immediately show something meaningful, so the user sees their previous products, and then you have to wait longer. Now we're connected to the local ones, connected to the remote ones, and we're good to go. A small interesting thing about this is that whenever you start storing devices in a database or products in a database, you also need a way of deleting them from a database. So now suddenly you need to build some kind of management in your app. So let's take it a step further. I already hinted at it. Let's also save the last state in the database. So if you save the last state, then you're assuming that when you start your app, that your product is still going to be in the same state. So then you can just already show it as that, and only when you know how to connect to them. So you only have to run the discovery, because after the discovery, users could start connecting your product. So if you look here, app starts, we're assuming that the devices are going to be in that state. We're going to discover them so we can allow connection, and then users can start controlling them. This was really, really fast, this mechanism, right? The interesting part is if you looked at the kitchen speaker, there we actually made a mistake. Because if I run this animation again, you would see that we are going to assume that the kitchen speaker is going to appear online as if it were on, but in reality, it was off. So we connect to the kitchen speaker, so we run the discovery, we know how to connect to it, so the user could start controlling it from now, but then slightly later we discover that it's off, and then your UI is going to flip back. This may seem a bit odd, but actually it isn't odd at all, because in reality, multiple users could be controlling your product at the same time. So these use cases where your UI suddenly updates without you interacting with it, that's going to be a valid use case anyway. So your UI is instant ready, and you can allow control after discovery, so now we're to 3 to 4 seconds. Optimizing this further is also storing the connection state in the database, and then you're just being really, really aggressive. You just remember the SSID of the last Wi-Fi network you've seen the product on, and the IP address on that network, and you're just, when you start the app, you say like, I'm going to assume that the app is still connected, that the products are still going to be connected like that, and the users could start controlling the UI immediately, I don't care, because everything is going to self-correct afterwards. So then you just open your app, and boom, everything is there. You could still make a mistake, like with the kitchen speaker, but then that would update later on. So all you need to do for that is remember the IP address and the last SSID. Okay, a pro tip to wrap up this section is, so basically your product could be in 3 connection states. It could be connected locally, so you need to communicate with it over a Wi-Fi network. It could not be connected at all, or it could be remotely connected. And typically for both the local and the remote connection, you need to run some subscriptions so you get like the latest events from the product so you always know its state. Well, a very simple way of simplifying things is not allowing the transition from locally connected to remote connected immediately. Just always push it through the disconnected state. From a user point of view, they're not going to see it because, yeah, in your Java code, it's going to run really, really fast. But from the number of states you have to properly handle as a developer, it gets a lot easier. Depends a bit on your architecture as well. So control speed. How do you make a product work fast? So basically, there's 4 things you can do. Make sure that you always use the local connection. Make sure that local connection is really, really fast. Reduce the amount of requests you do, and also do some UI tricks to make it look fast for a user. And if you look at this, then you may say like, huh? Why are we only optimizing the local connection? And that's because of 2 reasons. One, you always want to use your local connection if you can, because your remote connection, that goes over your server, so that has a cost attached to it. So it's simply cheaper to use your local connection. And 2, yeah, if I'm out of home, who cares that your products respond a bit slower? So if I tell my lights to go off and I need to wait for that for 5 seconds to happen, if I'm not at home, I don't care. Well, actually, also for you, that's not true anymore, because we do cloud-to-cloud integrations, for instance, with Amazon Alexa. So then suddenly the remote latency does get important. But when you're starting to build a new product, chances are that it isn't at the first day. So let's look into those. So you should prefer the local connection, fewer hops, it's always going to be faster. You have this cost saving, and you need to make sure that with the Wi-Fi, setup, I discussed that sometimes you need to force the connection. So also here, that's the same story. So how can you prefer the local connection over remote one? If you go back to our strategy pattern, we can throw a composite pattern in the mix. And what you then basically do is the composite strategy would have an ordered list of 3 strategies and would just try all of those strategies one by one. So it would just ask like, is the simulator strategy available? No, because it's not a debug build. Okay, is a local strategy available? Yes, okay, let's use that one. And then the remote one will only be used if the local one is not available. Very simple again, but very effective. Then optimizing local connection. I'm not going to cover this in detail. Basically use OKHTTP and make sure that you use all of the data compression, cache headers, and that you reuse sockets. If you want to analyze in depth the way that your products communicate with each other, your app communicates with your product, you can use Wireshark to do that. With that, we were able to successfully remove UDP, TCP interference. But one pro tip about that is, in this setup, Wireshark doesn't work, because what your product sends to your phone, that's a direct connection between product and phone. That doesn't get sent to the laptop. So if you want to sniff direct traffic between 2 things, you need to do a little trick, which is basically add 2 Wi-Fi networks and then put a hub in between. So then Wi-Fi network A would send everything via the hub to Wi-Fi network B, and the hub would also make sure that all of that traffic ends up at your PC. Not really hard to build, but it could maybe help some of you. Reducing the amount of requests. Here you have 2 main things that you want to do. If users do these toggle sequences, like on, off, on, off, on, off, on, off, on, off, you don't want to send every one of those requests because they are just meaningless. All you want to do is you want to make sure that you've sent the last one and that it ends up in the state that the user actually requested the last time. So that's one case you want to cover. The second case is, imagine if I do multiple actions on my product at the same time, for instance with lights. You could turn them on, set the brightness, set the color, and do some other stuff. Yeah, if possible, it would also be nice if you could combine all of those actions in one request. Well, again, there's a very simple way of doing that. What you could do is simply add a hash map. And in the hash map, you would put the key values that you actually put in your JSON. So the key would, for instance, if you set on, it would be key on, and then the value of is on. So if users would now press the button in your UI multiple times, then the key is always going to get updated in the hash map, but the hash map can have this key only once. So you would only have one value per thing in the hash map. What you also need to do is, every action you do, you need to make sure that that's also sent to your device. So you call send update, which simply tells the strategy, okay, do a new request. To the strategy, you could then pass the same object over and over again. For instance, an update request object, which basically has a get attributes method. And what it does here is it takes all of the values from that hash map and clears it again. You need some synchronization in order to make sure the thread's safe. But the really cool thing here is then the strategy could simply have a set, which is the queue, which will only contain every object once. And then all you need to do is you can always just add the request to the queue. It will only be once in the queue. And then whenever the strategy has time to execute that request, it would automatically combine all of your requests, make sure that the toggle sequences are gone. Very simple way, again, to solve this problem. At Philips Hue currently, we do more complex stuff, so we've built an entire active queue management system. But this would be a really good way to start, if you ask me. Then your instant UI. So have a look at the left and the right app. They basically do the same thing. They connect a loudspeaker. If you press the play button on the leftmost app, then it's not going to change state until the product has actually acknowledged the request, stopped playing, and stands back like I'm now in the pause state. So you press the button, and there's a big delay between play and pause. On the right-hand side, that doesn't happen. You press the button, and it immediately flips to the pause state without waiting for the product to respond. So this is a very simple way of making it more attractive to users. They also very cleverly do this animation where you rotate from a play to a past, which also then covers part of the time it takes for the product to actually start playing. Which one of these would you prefer as a user? The right one, right? And the only tricky thing about it is that you're assuming that your request is going to be successful. But yeah, your request should be successful, no? Because if that doesn't hold true, then probably there's something wrong in your entire system and you need to fix the bugs there so you can make this assumption. By the way, in practice, the leftmost app was a lot faster than the rightmost app in actually putting the player to pause. But the rightmost was a better experience. So final pro tip here, if you start optimizing the amount of requests that you do and that you cleverly combine requests and you don't send toggle sequences, as a developer, you may have this reflex like, yeah, but I've built the code, it works. Well, put a proxy in between, and we'll talk again after. I fell into this trap myself a lot of times already. Only when you really debug it, see what's actually happening, only then you can make those statements. So last part, handling hardware diversity and legacy. So developing a system. Imagine we're going to develop a new system. We have a team of 4 developers, and every feature that we build exactly takes 1 developer for 1 sprint. So the first sprint, we're going to build 3 features. Okay. But the next sprint, assuming that we have, for instance, 10% maintenance on every feature, we would also have a bit of maintenance for the previous features. And the next sprint, because the maintenance is recurring, we have a bit more maintenance and a bit more maintenance. So after 4 sprints, suddenly the 4th developer is also completely booked. So we have to drop a feature, otherwise it doesn't fit in the sprint anymore. And if you scale this and you scale it further, then you see what's going to happen. After a while, you cannot build any features anymore. You just stop innovating. So how can you fight that? The true cost of software, I hope you all know that, is in its maintenance. You're basically trying not to shoot yourself in the foot in the future, but in reality, you're going to shoot yourself in the foot anyways, so you just want it to be your small toe and not your entire foot, right? So focus on automated testing, big time. Don't just do unit tests. I hope everybody is doing unit tests. Is that the case? Is everybody writing unit tests? I see no hands at all, so let's assume that's a good sign. Also write integration tests for every single component in your system on the component level. So by that I mean isolate it as a component, so you don't want to do any networking there. And then add integration tests for your entire system, end to end. That also includes very, very basic stuff like a sign-up flow where the user creates a new account and then gets the email back to confirm that his account was created. That's also a flow you would want to automate because it's just so tedious to test and you want to have some kind of automated way in place to be able to capture that. Because all of those cases, they're only gonna increase and increase and increase in the future. And yeah, you need to be able to scale up, so you need to have that under control. So need for a good architecture is key. And what I want to make there, very explicit is like, a good architecture isn't an architecture designed by somebody who wrote or who read a design patterns book and then just implemented those patterns for the sake of implementing it. A good architecture is something that looks the way you expect it to look, looks ingeniously simple, and I gave a couple of examples about that, hopefully in the past couple of slides, but it's something that is also easy to scale. So over-engineering also has a tremendous cost attached to it. And then an interesting bit is, think well before you introduce a new feature. Because once you introduce a new feature, taking that away from consumers, that's not really an easy thing to do. And people nowadays have many, many different channels to be vocal, and so they are also actually quite vocal. But on top of that, the flip side of the coin is, they've bought your system, and they're also continuously expecting new features. So you need to be able to walk this line by choosing the right things to build to make sure your customers are excited and happy, but also to make sure that you don't introduce something which you may regret later on. So that's a fine line to build. And even at Philips Hue, we are sometimes still on the learning curve in order to get that right. So team-wise, focus on co-located teams, developing a system. Like you see before, you have software in the bridge, in the product, on the backend, in the app. Maybe you have an SDK, all of those kind of things. So you need to have a lot of interaction. So if you add an extra time zone into the mix or an extra location, maybe an extra Jira board, all of those things just complicate matters. So try to avoid that as much as you can. And also, yeah, but I think as a developer, you all know that teams don't need to be big to be effective. Usually, smaller teams can get more done than bigger teams. Then, I'm an app developer, so one of the challenges that we have is like, if you build an app, you typically don't build one app, you build an Android and iOS app. So then, how do you maintain consistency between both of them? Because the iOS app may program something into the bridge, and then the Android app need to be able to read that out and understand what it is. That's ridiculously hard to get right. And even if you manage to get it working, then later on you're going to refactor and improve your code, so it needs to keep on working, which is even more challenging. And if you're launching a new feature or a new product, because you want to cover all of the things we've mentioned before, and make it easy for users, make sure it's performant, you are not going to get things right from the start. You will need to try something out, test it with users, reiterate. And probably you need to have a couple of reiterations. So don't start developing a feature on two products at the same time, so on the iOS and Android app at the same time, because that's going to be a lot of waste. It's better to just take Android leading for feature A, and then after 5 iterations, when you think you got it right, then iOS can catch up, and the other way around. That's going to be a more efficient way of handling it. I'm an Android developer, so I also have some Android tips. Very silly, but a pitfall I fell into early on is trying to detect if a Wi-Fi network would have an internet connection, which you can do, by the way, but you run into a system timeout, a DNS timeout, which you cannot set and which is rather high. So trying to simply ping google.com, yeah, you need to wait for 30 or 45 seconds before that would actually give you a result. And then all of the code you need around that to be able to make the proper conclusions, that just makes it impractical. And the benefit you get out of it is simply none. So don't try and do that. It's not worth it. Run your tests in the JVM, then they're going to be super fast. If you build a new app, make sure you prepare for orientation changes from the start. You really don't want to be adding all of that code if you already have like 60, 80, 100, 120 screens. And if you listened well to my presentation, you're going to end up at that many screens, because at many times in your app, you need to guide the user very gently throughout the entire process to make sure that he can actually do the things he wants to do. And then another one, the final one that I want to touch upon is like, make sure you tightly control your threading and nullability. Have one line in your architecture. Everything on top of that is going to be on the UI thread, everything below on a background thread. And just pick that as a rule. It may seem obvious, but I don't want to tell you how many code bases I've seen where they're simply running stuff on the UI thread because they don't know which thread is on. They're on, so just post on UI thread or do on background thread. They don't have any control about that threading. So make a clear line, solve it there, and then threading is never an issue for you anymore. And same goes with nullability. I actually wrote through potentially interesting blog posts for you, like how to make your unit test awesome, and also why your app should actually crash, why crashing is not always a bad thing. Okay, so let's wrap things up. So I already mentioned this, but your design choices now are going to bite you back in the future, and it's typically going to be earlier than you expect them to return. So if there's a few things that I want you to take away from this presentation is that developing a connected product is hard, but developing a system is even harder. Maximize your local connections, try to get the most out of those, keep things simple for users, and really focus on the automated testing and make sure you get your architecture right. The key is typically also in the people. Making shortcuts is a very, very painful thing to do when you're building a connected system. Okay, the image credits, I didn't make those images myself. And then basically, that's it. So thanks for attending my talk. I'm Jeroen Mols, quite active on Twitter, and I also actively write a blog. So feel free to follow me there. Are there any questions? Yes?
What team size do you prefer? You said smaller than bigger ones.
Yeah. So what we currently try and do is keep our teams between 5 and 7 people. I think maybe even smaller than 5, between 4 and 7 people. I think 7 is already quite big. I would actually go for like 4 or 5. But the amount of, the challenge in also building an exciting system is that you have a huge backlog of things you actually want to build. So then in that sense, you need to make sure that you can have the right throughput versus still the efficiency of the team. So to be honest, that's also something we're still balancing a bit with and then seeing how well it goes. But I would say 5. Yeah.
From what you know of the systems that have been implemented, the home automation systems, what's the reality of in-home connectivity? Because we have thick walls, the Wi-Fi signals don't go through, you need multiple repeaters. I'm guessing that's a common situation.
Yeah, so the question was like, how well do connected systems basically work in practice? Because your Wi-Fi signal or whatever communication standard you use has like limitations. Through some walls it cannot go. Well, that's a bit of a difficult answer to. That's a difficult question to answer. What I can say is like we've had in the past, for instance, with an air purifier, we had issues where, if you would be in like Amsterdam in the Netherlands, the density of Wi-Fi networks around you could be so crazy high that the product simply wouldn't be able to index them all. And then your network you would want to connect them to, it would fall off that list. So those kind of issues, they are real, and they are also very painful for users because there's no general one-size-fits-all solution for that. So I think that's something that we as an industry are still learning on how to combat that and how we can better deal with it. You now have, for instance, the Google proposition, the Google Wi-Fi proposition, where you can buy like a Wi-Fi router which comes with 3 add-ons to make sure that you properly cover your Wi-Fi network. For Philips Hue, fortunately, what we have is we have a mesh network. So Zigbee meshes further, so you just need to make sure that you have a bulb in between bulbs, so then you can hop over one bulb to the other and you can infinitely expand your network. I think that makes our system significantly more reliable. But then still on the Wi-Fi side, if your Wi-Fi wouldn't reach as far, then still you would have issues there. So it's a complex and painful thing.
Sorry, it was kind of an extension of the first
No.
question. Is there anything in the protocol that reports back the quality of the connection that it has?
Within Philips Hue, you mean?
No, within the underlying protocol, the network protocol, or are there any IoT agents to detect the quality of connection?
Yeah, so the question is like, if you want to know in the field how well your connection is, are there any protocol-wise support for you to be able to measure that and to be able to keep the bookkeeping of that? That's the question, right? Well, actually, I haven't gone as deep as that, so I wouldn't know, but from top of my head, I can't really, I wouldn't really be able to pick out a thing. It's also, IoT is a very broad range because, what is IoT? For instance, we use a Zigbee network, but you could be using a Wi-Fi network or a Bluetooth LE network, and then the solutions per network layer are probably going to be different because Bluetooth LE, the characteristics are significantly different than a mesh network, obviously. Yes?
So when you initially connect your phone to the product, you talked about using Wi-Fi. What about the possibility of using Bluetooth so that you can maintain your connection to the product whilst the product is trying to find the Wi-Fi network?
Yeah, so that's a very interesting remark. So the question is like, instead of only using Wi-Fi to set up a product, what if you were to also add Bluetooth? So then you can, keep an open connection while the product is actually swapping Wi-Fi networks, so then you would have better feedback. Well, that's a super interesting idea, and what has historically held that back is the BOM cost. Because if you add an extra chip to your product, you also need to pay for it, so that would increase your selling price. So historically, the BOM cost has held that back. But if you look very closely at what now a lot of chip manufacturers are doing, they're increasing their integration, and then many chips are becoming combo chips. They would have like maybe Bluetooth and Wi-Fi combined, or maybe even Wi-Fi and Zigbee combined. So in that sense, I think looking forward, the economy of scale is probably going to make sure that that becomes more of a reality. But then again, also if you, okay, then you just need to handle a Bluetooth connection. It's probably going to make your life as a developer also easier. But then you need to have more firmware development in the product because you need to. So everything comes with a cost, right? So our time's up. Many, many thanks for attending this talk. Hope it was interesting.